Hello friends and students, most welcome to Dr. Acharya Academy. Today, after a long time, more than 2.5 months, I again started to continue the class on the Dr. Acharya Academy. By this time, I moved from Hyderabad to Ahmedabad. Today, we will summarize the whole chemical bonding and molecular structure that I described in several classes in the unit 4. You can check the previous class. First, we have seen this bonding and structure. It started with the causal's. Causal's first given the concept of the formation of electropositive and electronegative ions, and these ions formed to get the noble gas configuration of the atoms. So then these electropositive and electronegative ions are stabilized by the electrostatic attraction, and this concept gives the concept of electrovalency. Then the first covalent bonding, that first description is given by the Lewis. What he described that the sharing of electron pairs between the atoms, and again this is the process for the attainment of the stable noble gas configurations, and this is the concept how to share the electrons to get the noble gas configuration, and in this way the covalent bonding will be stabilized between the atoms to form molecules. And Lewis has given one dot symbols which shows the number of valence electrons. What I already described in the previous class. You please go through this class and we'll get a clear idea on this Lewis dot structure. Another is the Ionic compound, which can be pictured as a three-dimensional aggregation of positive and negative ions, and these positive and negative ions will aggregate in respect of three-dimensional structure to form the ordered arrangement, which is called the crystal lattice. So in a crystalline solid, that means when the crystal lattice is formed, it is called the crystalline solid, and there is a charge balance between the positive and negative ions, and this crystal lattice will be stabilized by the enthalpy of lattice formation. That means the release of some energy when the crystal lattice is formed. And we know that when the energy is released, in next chapter in thermodynamics we will go in details, then the crystal lattice is stabilized by releasing the energy in respect of the enthalpy of lattice formation. A single covalent bond, when it is formed by sharing an electron pair between the two atoms, then multiple bonds also form by sharing the 2 or 3 electron pairs. Single covalent bond formation by one electron pair, but multiple bonds are formed by sharing the multiple electron pairs. Some bonded atoms have additional pair of electrons which is not involved in bonding, and this is called the lone pairs of electrons. In the Lewis dot structure, you can find the arrangement of the bond pairs as well as the lone pairs around each atom in a molecule. Another important parameters like bond length, bond angle, bond enthalpy, bond order, and bond polarity that I also have discussed in details in the previous class. And these all has significant effects on the properties of compounds. A number of molecules and polyatomic ions which cannot be described by this single Lewis structure, and a number of description, that means representation based on the same skeleton structure are written. It means that when the number of molecules or polyatomic ions will form which cannot be described by a single Lewis structure, and in between whatever electrons is there, it will go move different place in the atoms, and then the same skeleton structures I already described this, and these skeleton structures is taken together represent the molecule or ion. That means any single structure you will be unable to describe the molecule. You have to consider some skeleton structures together. That means the number of description, which is called the resonance. So now the concept has come, the resonance, which you can find in the previous class in details. You please go through that class. So these structures, that means the number of descriptions, whatever I told, is called the canonical forms, and it constitutes, these all constitutes a resonance hybrid, which represents a molecule or ion, what I already described. Now, another model for the bonding formation is called the valence state electron pair repulsion model. In short, it is called Bsepr model, and it is used for predicting the geometrical shapes. Because in the previous case, the scientist trying to understand the normal bonding formation, but Bsepr model first try to geometrical shapes of molecules, and the assumption is that electron pairs repel each other and therefore tends to remain as far as possible. That's why it is called the electron pair repulsion. That means electron pairs will repel to each other and they will find the optimum place for this to get a definite geometrical shapes of molecules. And in this model, the molecular geometry is determined by repulsion between the lone pairs. Lone pairs I already described, and lone pairs, bond pairs, and bond pairs and bond pairs. Three different ways the repulsion will happen. First case is the lone pairs, second case the lone pair bond pairs, and third case the bond pairs. And with this repulsion, molecular geometry can be predicted. The order of this repulsion is the greatest value, that means highest value of repulsion for lone pair, and lowest value of the repulsion for bond pair, and lone pair, bond pairs, its value of repulsion is in between. So another concept, the valence bond, in short it is called VB approach to covalent bonding, is basically concerned with the energetics of covalent bond formation. I already described in the previous class, about which the Lewis and Bsepr models are silent. So basically what valence bond theory discussed, it discussed bond formation in terms of overlap of orbitals. So in the valence bond theory, another concept has come, overlapping the different orbitals of different atoms to form the molecules. Example. Is the example H2 molecule. That means same atom, two atoms form one molecule, hydrogen molecule from two numbers of hydrogen atoms. And involves, we know that hydrogen atom has only one s orbitals. So two hydrogen atoms has two orbitals and they are overlapping. And And in that way, the potential energy of the system get lowered. That means when overlapping is happening, then potential energy will be lowered, and it will favor the formation of the molecule from atoms. In this case, the hydrogen atoms. So at the equilibrium, the internuclear distance, which is called the bond distance, the energy touches a minimum. That means when the bond is formed, energy should come a minimum, and that minimized energy is the favored for formation of the bond. And bond distance predicts that at equilibrium, the energy of the participating atoms will go in minimum side. So any attempt to bring the nucleus still close together, beyond this minimum energy, if you try to bring the nucleus more closer, then what will happen, that it will destabilize the molecule, because of the again increase due to the repulsion of the nucleus, participating nucleus, the energy will increase and destabilization of that molecule will be happening. And because the orbital overlaps, the electron density between the nucleus increases. That means participating nucleus, whatever electrons they have, and that electron density also will increase, which helps to bringing them closer. That means overlapping is nothing but that electron density between the nucleus, two nucleus. Nucleus means belongs to the atom. In between, electron density will increase, and electron density increase means it helps in bringing the nucleus closer. But if you want to make further closer, then repulsion will happen between the nucleus, and it will destabilize the molecule. So the actual bond enthalpy and bond length values are not obtained by overlap alone, and other variables have to be taken into account. So another explanation is the characteristic shape of the polyatomic molecules. This molecule having two or more different types of atoms. Then Pauling introduced the concept of hybridization of atomic orbitals. That is another improvement from the overlapping of similar orbitals. And I already discussed about the sp orbitals, sp2 orbitals, sp3 orbitals of hybridization of atomic orbitals, which happen in the beryllium, boron, carbon, nitrogen, and oxygen atoms. And these all are used to explain the formation and geometrical shapes of molecules like beryllium chloride, boron chloride, methane, CH4 means methane, and ammonia NH3, and obviously our water molecule H2O. And in this method, that means hybridization of atomic orbitals, with this hybridization, you can explain also the formation of multiple bonds in acetylene and ethylene. So after that, another concept has come, another theory has come, which is called the molecular orbital theory. In this theory, the bondings are described in terms of the combination and arrangement of atomic orbitals to form molecular orbitals that are associated with the molecule as a whole. That means whatever number of atomic orbitals in the different atoms which are forming the molecules, you have to consider as a whole. That means all atomic orbitals you have to consider as per the molecular orbitals theory. The number of molecular orbitals, you have to remember, it should be always same that means equal to the number of the total atomic orbitals from every atoms from which this molecule are formed. Molecular orbitals, bonding on molecular orbitals, and antibonding molecular orbitals. These also I described very clearly in the previous class. Please go through this to get the clear understanding on it. So now electronic configuration. How to give the electronic configuration of the molecules. That also I described, that filling of the electrons in the molecular orbitals in order of the increasing energy levels. Whatever the bonding and antibonding molecular orbitals is formed, there one chart is there where you can see the increasing of the energy levels of these bonding and antibonding molecular orbitals. And on this table, from the lower to higher side of energy levels, you have to fill up the electrons to get the electronic configurations of that particular molecules. As in the case of atoms, another concept, Pauli exclusion principle and Hund principles are applicable for the filling of molecular orbitals. Pauli exclusion principle and Hund rule I already discussed in an elaborating way, and these two phenomena also applicable for electronic configuration or the filling of the molecular orbitals in a molecule. So here a little bit description is there. Molecules are said to be stable if the number of electrons in the bonding molecular orbitals is greater than the number of electrons in antibonding molecular orbitals. And another concept is hydrogen bond, that also described in this unit in the previous class, which is formed when a hydrogen atom finds itself between two highly electronegative atoms. Examples already I have given in the previous class. And intermolecular hydrogen bonding also possible. That means two different molecules, that also I described very clearly. And hydrogen bonds have a powerful effect on the structure and properties of many compounds. And we know commonly that when the water forms the ice, then hydrogen bonding is happening between the water molecule. And this is also another example of the intermolecular hydrogen bonding. I hope that if you go through all the class of the unit 4, then you will understand clearly each and every aspect in this bonding formation, the molecules geometrical shape, how to happen, and hybridization, that is very important thing, and hydrogen bonding and other phenomena. And with this, I'm completing the unit number 4. And now I'll start the unit number 5. Thank you so much